Good morning, everyone. Navin just give you a very beautiful picture and a huge benefit of partial upgrading. And I will talk about some technologies we are working on to help us get there. So this graph shows from the economical and the technical point of view what partial upgrading is about. When you look at this graph, we are really looking at this sweet spot where you have a low cost and a low complexity process to make you get a pretty reasonable return of your investment, and to help us to reduce the diluent for bitumen transportation, and also increase the market value. So when we talk about partial upgrading, we need to remember two keywords here. That is low cost, low complexity. So what we are working on now in our current partial upgrading portfolio, we are working on majorly in three domains. One is the conceptual research. It's, as you see here, is a majorly 300 millimeter autoclave lab test. And second domain is small pilot testing. It's really to prove the concept and prove the engineering feasibility. The third domain is field pilots. You can see that it's very much like a real plant. So this graph basically gives you an overview of our current portfolio. So in the first domain, we have new conceptual projects. Usually we have about 10 to 15 projects with investment in a range of 100K to 4.5 million. And we partner with industry and university. So these are majorly university projects. In the second domain, you can see that we do small pilot with a capital ranging from 1 million to 70 million. Our major partners here are Field Upgrading, Husky, Mega Energy, WRI, Chemet, sorry, I missed that one. The third level, we currently have one, is in the field demonstration. That's Mega Energy's 1,500 barrel field upgrading project. So when you look at the graph, these three levels of project, you can see that there's two big areas really shows what we as AI-EES play in this whole portfolio. One important thing for us to do is that we ensure the knowledge flow between these three levels. It's very critical for people to understand from the fundamental side of what's the operational and economical challenges the industry need to deal with. On the other side, from industry side, we need to know what's the best technology in the science and engineering front. So only by collaboration of all these levels, we can get a real breakthrough. That's what we need in the partial upgrading era. As everybody knows that we don't have a conventional technology, and we need to work together to develop a viable process. The second role we play here, you can see the arrow is really to integrate and link all the resources and expertise around there. As a few of my colleagues say that you need to make the use of the best talents, brains in the world, and also the resources to get you to the goals. So how we develop projects, For us, it's always like we need to develop projects to address the key gaps identified by us with our partners. So our ultimate goal in pressure upgrading is to develop viable process that can upgrade bitumen to products that the market wants. As part of that, we also do process integration. It's very important for pressure upgrading to reduce the cost. So integration is another very well-identified gap for us. Currently, we have working on like immersion upgrading and integrated with in situ, and frost upgrading integrated with mine extraction. So to get us to the new process, we also identified three fundamental research areas that could make breakthrough to pressure upgrading. First of that is asphalting chemistry. So we know that the key issue for bitumen upgrading is really about how to deal with asphaltings. So in that domain, we have research on aggregation, deaggregation mechanism, and understand separation of asphalting, conversion, reaction pathways, and characterization and modeling. The second fundamental area is novel catalysis for hydrogen addition. We know that at some point we need to add hydrogen to bitumen to upgrade it, but we cannot use the traditional one because everybody knows what's the challenges there. So we are working on that area. And last, we work on olefin and diolefin control. That's really something particular to pressure upgrading. So today, because the time limit, I will focus on our work on olefin and the diolefin control. However, in the future tech talks, we will provide updates on each particular important gap area. So olefin, so what exactly is the olefin issue we're trying to solve here? So we know that when we look at the current pressure upgrading process concepts, almost all of them have to deal with olefin in the final product. So currently, we are using hydrotreating. That's the traditional process. That's what we do with Mega Energy. So basically, you hydrotreat the distillates to saturate olefin, and then blend it back with the heavy part of the partially upgrades the bitumen to get the crude. So usually we have about 1 to 5% weight percent olefin in the crude without hydrotreating. Depending on the process, the olefin can go to 10%, but that is not really our focus. So we're really focused on this range because majority of pressure upgrading process sits in this area. So we know that hydrotreating has an issue. So basically, they need a hydrogen plant, and they add some complexity to operation. So if you remember, the two keywords I mentioned at the beginning is low cost, low complexity, and hydrotreating doesn't really fit in that area. So that's why we want to look for new technologies to deal with olefins. To differentiate us from traditional hydrotreating, we must understand that our goal is really to satisfy the pipeline specification. So that means undetectable olefin, or you can say it's less than 1% MR detected olefin. And the second goal is really to reduce the cost for pressure upgrading and reduce the complexity. So so because our goal is different, so that means our process will be totally different with the traditional hydrotreating. Because most of this part of work is confidential, now I would like to give you conceptual idea to see what we are doing now here. So this graph here shows you concept patented by Nexon. So basically, they called catalytic olefin aromatic alkylation. So the idea is that you use aromatics and olefins in your partially upgraded crude and make them to combine into alkyl aromatic. By doing that reaction, you actually get rid of olefin without saturate your olefin bond. So basically without using hydrogen. So that is the chemistry we are looking for to solve the olefin issue when we talk about olefin reduction without hydrogen. So that's one example, but that is not the project we are working on. We do have projects on this one to reduce the olefins. So we are working on other concepts. We did deliver some very interesting results in past couple of years. We have one new process concept proven in the lab, and we have a patent application pending. Now we are working on two new potential projects with our university and the industry partners. And so stay tuned. We'll have more exciting results to report to you in the future, probably after a couple of years. So I want, Nevin talked about national program. I want to just recap of what we are doing under this program, because what we talk about partial upgrading all fits under this program. Since we established this program last year, we get much better platform to work on partial upgrading. The national program is really a platform that will take advantage of, or should I say, to integrate the resources and expertise of both federal, provincial, and the industry, and the academia societies to make sure that we get the best resource and get the best talent to deal with a critical challenge we have in Alberta. I believe that we will have more results coming out of this program. And so that's my presentation today. Thank you.